Hey, what is up guys? Now we're gonna move on with concurrency and we're gonna talk about channels, which is a great mechanism for synchronizing routines that need to cooperate together. So basically a channel is an abstraction. You put something into a channel and then somebody else is on the other end reading things from that channel. It can be one reader reading from it, it can be multiple readers reading from it. So you can use channels to synchronize these routines, and maybe you have a producer that's producing things and putting them into a channel, and then you have consumers that are reading from that channel waiting for more work to come in. The cool thing about channels is that it has blocking behavior when the channel is full, if you're using a buffer channel, meaning that it's a channel that can hold multiple things, or if your channel doesn't have a buffer, whenever you try to put something in the channel, you as the producer, you will block until somebody else can read it. Or the other way around, if I try to read from a channel and there's nothing in it, I will block until something comes in. So you can sort of coordinate routines like that, and I'll show you an example now. So the first thing to do is we're gonna make a channel. So I'm gonna make a channel called nums. You make a channel with the make function, just like you do maps or slices. And you say, I wanna create a channel of integers. The way that you write to a channel is with a little arrow. I'm writing the number 2 into this channel. And then you can read that number with an arrow coming out of the channel. And then let's print that. So let's run this and see what happens. Error, all routines are asleep, deadlock. What does this mean? It means that it created a channel, and when it writes the 2 into the channel, it blocks, right? Until somebody can read the 2. I'm reading it down here, but it already blocked up here, so it's never gonna reach this line. If you do the same thing, but in the reverse order, the same issue will occur because it's trying to read something from the channel. The channel is empty, so it blocks here. So let's create a function here called writes number 2 or something like that. It's going to receive an integer, a channel of integers, and you can say that you want it to be a write only channel with this little arrow here into the channel. To make this a little more interesting, let's block this routine for a little bit. Let's just say something like waiting for number 2 to come in or something. So let's run this. We're waiting, and then 2 seconds later, the number 2 comes in. Okay, so you can see how this routine is blocking until this routine finishes, right? So you can begin to see how channels can be used to coordinate routines. Maybe you have a producer putting things in a routine and then multiple consumers reading from it. In fact, I have an example from work. Basically, what we're doing is we have a SQS queue, which in AWS, it's a queue for messaging. And whenever we receive a message, we have to do this long operation to process that message. As I'm reading messages and I'm giving it to a worker pool, and I have multiple routines sort of on each core processing each message, at some point I run out of cores. So all of my routines are busy, so nobody's reading from that channel. As the routine that's polling SQS is saying, hey, are there more messages? Are there more messages? Are there more messages? Let's say it receives a batch of messages. It tries to put the messages in the channel, but the channel is full because everybody's working, no one is trying to read from it. So then that routine that's polling SQS is gonna block automatically. And so now I get this synchronization where as each of the worker routines finishes their work, they go try to read from the channel, and now that other routine that was blocked because the channel was full becomes unblocked and it starts polling again. So I can sort of pause and resume polling SQS for free with this approach. Again, you can have multiple routines reading from a channel and multiple routines writing from a channel. Now, there are a few things that I still need to cover. Namely, your channel can be a buffer channel, meaning let's say that you put a 2 here. This means that, let's say the channel is empty. If I put something in it, it's not gonna block. It's just gonna go into this buffer. If I put something else in it, it's not gonna block. Now when I put a third thing in it, then that third thing is gonna block until somebody frees up a slot in here. Another thing that you need to know about channels is that you need to close them when you're done. You need to do close and then the name of the channel. There is one problem though. When you're reading from a channel, like I'm doing here, you can, like you're doing from a map, you can say, I want the value, and when the channel is closed and you try to read from it, you read the 0 value for that type. So in this case, the 0 value for integers is 0. I'm gonna get a 0 here. I'm not gonna get null, right? I'm gonna get nil if this were a pointer to integers, but it's not a pointer, okay? So I'm gonna get a 0 here, and then this is gonna be true because the channel is gonna be closed. So I can use this to know, hey, is this a legit 0, like somebody pushed 0 here, or is it returning 0 because the channel is closed? And that way you can know. The problem with channels is that when you write to a channel, like I'm doing here, if I try to write to a channel that was closed, it will panic. Let me demonstrate that. I'm gonna close this channel. Panic, close of a closed channel. Okay, this was, it closed here. Oh, you know what's happening? When I'm closing this channel, this guy automatically unblocks. So this finishes. All right, let's do this. There you go. So it's panicking because I'm trying to send on a closed channel. What does this mean? It means that you can never close the channel from the receiving end. The coroutine that is receiving the messages, if they close the channel, unless you somehow signal that to the channel that is pumping messages, they will try to push something on a closed channel and you're gonna get this exception. So ideally, you would always close your channel. We can do it here, right after we write to it. The coroutine that is writing to the channel should be the one that closes it. Now there are scenarios where you know for sure that you can close the channel even though it's not the coroutine that is pushing values to it because of some condition, you know, like if you get here then it means that there are no more messages, so it's safe to close. So alright, so that's an intro to channels. There are more things to cover, like let's do something useful with them, let's merge. You can take multiple channels and merge into them. I'm gonna cover that in the next video. So alright guys, this was it. I'll see you guys in the next one.